All right, so yes, it's been a while since we did our last catchment assessment. As Matt alluded to, 2015, 2016 time period. So what we'll first start to do is travel back to that pre-pandemic time and visit what that rule set was in a little more detail, get down into the weeds a little bit so we can understand how we can improve upon it and expand it and make it more flexible so that all states can contribute to the assessment themselves and not be dependent on a third party like myself. So back for that 2015 assessment, we put a request out to the states and federal agencies and tribal lands where appropriate for all of their data on salmonid presence. And they
recording in progress.
and they returned us that data sample points. So we had the coordinates of the location, the date that it happened, and then the species, either a count or just a presence, absence of those species there. And so I guess I should preface this that when I was brought into this project, Mark Huddy had been working on the NHD Plus version 1 catchment layer for the southern states, and by southern states that's basically Virginia South. So he had already gone through, got those states' data, kind of hand-coded all those catchments, went back out to the states, met with them, looked at maps. They did all the edits, and all that was completed. Then they looked at the northern states, and they saw how much more area there was, and they realized that that was probably not a feasible way to do it. So we wanted to go with an automated procedure. So we developed an algorithm that used, at the time, NHD Plus version 2 was out, so we updated to that for those states, so Pennsylvania North. And from the NHD Plus data set, we used the catchment layer, and then they have the flow lines and flow direction layers as well. And we also used some barrier layers. Primarily, it was just big, large dams, so from the anthropogenic barrier data set. The Nature Conservancy provided their dam data set to us as well. And then several states did provide, they had their own kind of natural barrier data sets in the form of waterfalls. So those were put in, I should say impassable waterfalls, so those were put in when we had them. So all that data was put into this simple rule set. Basically, we got the point, we found what catchment that point was in, and we used the salmonid species that were present at that, in the most recent sample, or sampling year, in case of that catchment had multiple samples within a year, and classified that catchment by that species assemblage. And we moved upstream to connected catchments that did not have their own sample points and used the classification from the downstream sample as an inferred classification for those catchments. There's been this 10-year rule that was been implemented where if the sample itself was more than 10 years old, the classification ended in a P for predicted. This is kind of a carryover, but it's useful because it kind of gives you an idea of where you haven't been in a while. So we maintain that rule. And unlike what Sean just described, we did not do any downstream movement of a sample point. So we just, if there were trout on the catchments below and they weren't sampled, then we did not detect them. And this is kind of what Nat went over. We had the classification codes, either there was no salmonid, so it was 0, or you had a species by itself. So brown, rainbow, and brook trout, or we had some form of sympetry. These are the codes that had been used in the past, and they continue to be used today. There's also another code, 0.5 for stocked populations, and that is still in use as well. So this catchment, when it was completed, the layer was available to view and download at ecosheds.org/geocyber/www, which was kind of our first go at a web tool. So this one's been around a while. Maybe you've seen it, maybe you haven't. It's still up, it's still running, and still houses the data. The catchments themselves are there, obviously. And if you wanted to download them as a geodatabase, that is still there as well, and the documentation for that whole process, including all the metadata that goes along with those layers, is available as a download. So to dig down in the weeds a little more, so that when I'm talking about the new updater, it makes a little more sense. When we walked upstream from a sample point, we followed the flow lines up through the catchments, and it's dendritic in nature, right? So as we go upstream, it branches, and you get different routes up through that. And so in this case, our number one, the numbers here represent this column called catchment count. And this is basically how far, or the number of catchments upstream you are from where that sample point occurred. And in this case, the sample OID was the object identifier of the sample point in the data set. So in this case, we had one sample point used to infer all the catchments upstream. And you can see that there's, even though it branches, you still get anything that's greater than 1 in this catchment count value isn't assumed to be inferred, or I'm not assumed to be, is inferred from a downstream sample. So these two fields will be resurfacing later on as I walk through the new tool. So as I mentioned, that algorithm was only performed for the states from Pennsylvania north. So those two fields I was just talking about, catchment count and sample OID, are really only applicable to those states. For the southern states, like I said, Mark had used NHD Plus version 1. We didn't want to go through the whole process of rerunning them and revalidating those catchments, since the states had just done that with Mark. So what we did was we turned the NHD Plus version 1 catchments into points, and then did spatial joining, and using the classification code of that point, and classified the catchments by running those points through the algorithm. So you end up with basically a catchment count never greater than 1 for those states, the southern states. And the last thing we did in 2015 was aggregate those catchments into patches. So the rule set, again, was pretty simple. We used just the catchment layer itself. The downstream terminus of the patch was either the absence of the target species or the presence of a barrier, in this case a dam or a waterfall. And then it moved upstream through the catchments until either the target species was not detected, or there was a barrier, or you reached the stream's end. And again, these were coded, the patches themselves were coded by the Salmona species that were present within the catchments they contained. And there were just under 10,000 patches for that 2015 layer, and as Sean just showed, this is biased high, right? Because we know there's a lot more fragmentation out there that we didn't capture with just that large dam barrier set. So even this biased high patch there, the mean size was less than 2,000 hectares. And again, this is available at the site I just showed you earlier. So moving to our current assessment, we wanted to continue to use the NHD Plus version 2 catchments at this time, because we haven't done an assessment in back-to-back instances where we can compare apples to apples to get direct comparison for changes. So this kind of addresses what Helen just brought up as well, and tracking those changes. Sean, I didn't ask, what layer were you guys using NHD Plus still version 2 catchments, or were you using the high res? Or?
I think Pennsylvania was the high res.
Okay,
so the updated stuff and the smaller scale stuff was high res where available.
Yeah. Yeah, so that is out there, and I'll bring that up again at the end. It is available across the range at the moment, but again, since we've never had a chance to do direct comparison between two assessments, at this point we're going to continue with the NHD Plus version 2 catchments. So the task at hand here was to kind of create a web platform that would allow the states to be able to self-update their own catchment classifications. We did this because we wanted it to be flexible. This way the states can perform the update at any time. So when they have their data in hand, they can do it on their own time frame. And also, in this instance, you can have multiple users work on a state. So if you have different biologists that know an area much better than another one, they can go in and do just their area. So when users register, they will, for an account, they will be given privileges to make edits to a state, a specific state or states, depending on their affiliation. We also wanted it to be convenient. So when you make an update in this platform, it'll be in real time. So as soon as you make that change, it'll be reflected for everybody to see, that's available to see it. And we wanted to make it convenient in the way that it's used, so we don't require any kind of GIS software at all. Everything's done right through your web browser. So for now, we will go right to the tool. So there is a tutorial. It walks you through some of the steps. It needs to be fleshed out a little more, and I will do that over the next few weeks. For now, I'll just walk you through that. There also is some information about it, such as what it's running on, the data sources and things like that. That also needs a few updates, but it's mostly fleshed out there. The tool itself, you can change the base layer to be whatever is most convenient for you, whether it be satellite or topography, or you're a fan of Google or Bing. Either way, it's all there. You can add overlays such as HUCs, states, counties, and also you can add the patch layer and obviously the catchment layer, which is what we'll be working on. If we add a layer, any feature you click on, it tells you what it is. Sometimes you have to zoom in a little bit to get right on one. Yeah, so no matter what's up, those layers will automatically be displayed when you click on the map. The layers themselves, everything's draggable, expandable, movable. So if you want to change the opacity or change the order, everything can be done right in the legend window to bring it to the top. So let's go. Since Sean was in Lock Haven and I live near Sean, we'll go back to Lock Haven. We'll add the catchment layer itself. All right. So click on catchment. Basically, it brings up all those fields that we just saw in the presentation that came from the original, 2015 assessment. So the stream order, stream catchment count, and sample OID were the ones I was showing you. It also tells you what it's currently classified. So this is 0.2, so that is brown trout. If we want to edit it, I guess the first thing I should do is actually log in. So anybody can register for an account. It'll you'll just fill out your email and a password and a little bit of information and submit it. It'll go through and it'll send you an email to confirm it. That email oftentimes gets sent to the trash because it's coming from a bot. So make sure if you do register and you don't see a confirmation email, just check your trash. Log in. So we wanted to make this simple, right? Really, there's two ways to change a catchment. You can do a manual edit where you're just editing one catchment at a time, or you can import a file of changes. So we'll start with just the manual edit. When you bring it up, click on catchment, it'll populate that feature ID. We wanted to know what you want to update the code to. So in this case, all the options over there. So it's currently 0.2. So if we want to change it, say we got rid of brown and we change it to Brook Trout. We did that today, and it was a new sample. We can update right now, and we successfully updated. It'll redraw. And that catchment is now, when the half piece of the pie shows up, it is now Brook Trout. So that catchment has been updated. And what it did is it added some fields to the table in the underlying database. So the prior code was 0.2. It was called originally from a sample in '97. We changed it because we had a new sample. We changed it this date. I'm the one that changed it, so it logs whoever was logged in at the time is recorded. Changes the date that or records the date that it was edited and any prior edits that it was. So that's the easy way to go in and change that. Manually update. But there's a lot of catchments out there, right? And we don't want to have to do that by hand for thousands of them. So in this instance, if we looked at this one was upstream of that one, the downstream catchment. So what we could have done is say I wanted to update it and I wanted to extend that upstream. So I want to change anything that was inferred from this catchment to the new classification. And if I hit update now, whoops, to 1.1. So now we updated, oh, because I wasn't downstream. That's why. So I would have had to been on this one. I still updated it, but I didn't move upstream because I was on the catchment itself. But you get the point, the idea that you can use those two fields to your advantage to change them all at once. The second way to do it is to import a file. So the file can be a CSV or an Excel file, doesn't matter. And it's flexible. You can have lat and longs and species present, or you can have if you can have the feature ID of the catchment that you want to change, and the new code that you want it to update to, and the date and the reason. Any combination of those things can be used, depending on how your data is stored in your states database. So we would want to import a file. We would then choose one of the files. In this case, I'll do probably the most common will be species and coordinates. So then you toggle these options back to fit whatever you have. So if you had feature ID, you would click that. If you have coordinates, you can go back to this. And then you map those fields to whatever that field was called in the file. So it doesn't have, these can be anything. It doesn't matter what it is. It'll show up in this list. You just map the appropriate field. If you have stock information on stock brook trout, you can use that. If not, you don't need to. Same thing with notes. If you want to supply notes, you can. If not, you don't have to. So then we go to update, and we're presented with a table of all the changes that will be happening. If you click on the feature ID, it'll zoom you into that catchment. It'll show you what it currently is, what it's going to be, the date of the previous sample. There's also this flag field. I'll show you another example of that in a second, but that just will populate if the catchment is, or the feature ID of that catchment is in there multiple times, which is a good chance of happening in NHD plus if you have multiple headwater streams in a sample, or even multiple samples within the same stream. What it does is it sorts by the feature ID and the sample date for that feature ID, so they should all be grouped together. So at this point, you can choose to make the edit or to not make the edit. If you chose, for some reason you thought, well, I don't want to change that one at this time, you can simply click on it to remove it. You can also download this to a CSV file to go in and do further research on these if you wanted to. So this will just download that data. And you can filter this list, so if you show flag, nothing flagged, so nothing's going to show, but if we show ones that are going to change, so in this case we have this catchment that's changing from brook trout to rainbows and browns. You can look at that. Once you're happy with all those edits, you can go ahead and choose make edits, and that is run, and we successfully updated 2 catchments because this one was not selected, so we hit OK. And now that is a brown trout catchment. I will show you the flags that do pop up. So if we go back, we want to import a file. We will import so you can see this one obviously has different titles, but doesn't matter, it's flexible. So this one has a file of about 20 or so updates. So now we see that this flag, and so in this case there are 2 records for this catchment. You can see 1 and 2. In this case they're both the same. So it's not a big deal, but you can imagine scenarios where these will be different. And then a decision has to be made as to what we ultimately want to call it. So in this case you could turn one off. And I'm not going to make the edits here, but same thing once you run through it. Those edits will be updated, the table will be updated, and all those changes will be recorded in the table itself. So that's the whole tool. So we try to make it simple and straightforward to use. On the back end, so this is all running on a database that's where the table gets, the most important thing to me was that any changes that are made are not lost. If something happened, the server went down or something. So that data gets backed up. That data gets backed up to Amazon AWS daily. So Lori and I got ourselves an account with Amazon that she can put on her credit card.
We had a bill for 15 cents, literally, that I had to submit as an expense.
So we've been doing this since February, and we're paying 15 cents. So we chose Amazon AWS S3 Glacier, which is kind of the cheaper storage. It's for rarely accessed files, but you can restore them if need be. So in that case, it's 0.0036 cents per gigabyte of storage space. So, and every night we're storing that table, the table that all the catchment data is in. And we're keeping that copy of each one of those days for 1 year. And then the first of every month, it updates, or it backs up the whole database, all the other layers as well. And we're storing those monthly copies for 2 years. And then on January 1st of every year, we're making our yearly snapshot of the database, and those we will keep forever. So we can go back and get any of that data at any point in time if anything did happen to go wrong. For me, this was the biggest priority before I felt comfortable even rolling this out. I just wanted to make sure any investment and time that people put into it wasn't wasted. All right, we want people to use it, and we don't want them to be turned off by it. So this is running. This is that's important. So next steps is that we're pretty much at the phase where we want people to mess around with it. We want them to try it out. We want them to break it so that I know what bugs are in it and what needs to be fixed. So we're proposing that the states register for accounts. Anybody that you feel should have an account and make changes to your state's data should register. Like I said, you can register on your own, but you won't be able to make any edits until you are given permission in the database itself. So we will vet all those accounts to confirm that they should be able to update your state's layer. And then once you have your account, we're putting out like a 1 month time period here where we're calling it a sandbox, where you can just go and play. It doesn't matter what changes you make, because these are all going to be erased at the end of the month period. We just want people out there using it and seeing not only what potentially, if there's any issues or bugs that pop up, but also what features that we don't have in it or functions that we don't have in it that would really help you to streamline using this, because this is what we really want. We want people to use it. So anything that you see that would help decrease your workload and make you more likely to update this, let us know. After the month, we will fix any issues or bugs that do arise. We will try to incorporate as many of the requested features or functions that are out there. And then we will reset the catchment data, and at that point it will be live for update. And that brings me to a bunch of short-term questions that would be great if we could talk about, maybe get some answers to, as to how we want to go about, I guess, archiving this data and sharing this data is really what it comes down to. So when do we want to release a time-stamped or versioned file, catchment layer to the public? So we're going to want to keep track of these, right? So this is what Helen Neville was saying. So if we want to track changes, we need to keep track of these versions that are out there. But we can't, a daily release is too much, so it's probably something greater than that. But it'd be great to get some discussion on what that time frame is. How often to create a patch layer. So all we're doing is changing the catchments. We're not rerunning the patch layer. And for better or worse, the patch layer is running on whatever is currently running on the barrier data set that we used in the 2015. If we want to maintain an apples to apples comparison, maybe we leave it that way. If we don't, maybe we start to include more of these more informed barrier data sets that are more and more states have. NAC did a lot for COVID. That data set's big throughout the Northeast. I know a lot of other states have their own version of that, right? They've been going out and visiting COVID. So if those are out there, do we want to incorporate them now? And maybe the patch layer is not as important as the catchment layer in terms of tracking change. I don't know. That's all things we can talk about. Where do we want to release these layers? So we still have, obviously, the original website, which is still functioning. Do we want to add them to that, or do we have another warehouse that we want to add them to? And this came up when I was discussing it with some other members of the Science and Data Committee, is do we want to restrict just viewer access of this catchment layer, which right now anybody can look at? Do we want to restrict that just to people that are registered users? So in case, I don't know, so people don't run away with the data. There's no way to download it at this point in time from that screen, but you can take screenshots, obviously. So those are some of the short-term questions. And then a couple long-term questions that we've already hit on a little bit is like when and if to transition to NAT plus high resolution. So that's, the image shows kind of where the status of that is. So everything is available. There are some regions being updated. It looks like the Chesapeake and maybe the Tennessee Valley regions. One that always comes up is how to expand beyond presence absence. That's a tough one. And after just watching Sean's presentation, is there more synergisms that we can come up with where we can combine our efforts with others to really add value to this resource? So with that, I can take any questions, or we can go right into discussing some of these other questions, or we can do whatever we want.
Yeah, let's, Kristen, can you enable my camera back, please? I'll turn it on. Oops.
Jason,
There we go.
How do you feel about at some point in time entering like or something like that into it to keep track of that, or potentially have a layer that allows you to elicit callers dependent on fish densities or prosperity of the population and how robust they are? Is that useful? Do you care?
Yeah, I mean, the bottom line is we can do anything. The question is how much effort is it, and how difficult will it be to implement, I guess, and how useful will it be? I don't have a great answer to the somehow go beyond presence absence. I know, Jake, if you're on, I don't know if you want to start talking a little bit about some of the stuff that's been going on down in your region, to show, kind of highlight some of the potential that could come out of this, or, maybe it's just something that other groups do that we can then use, we can grab onto that data. So, I mean, that's a big undertaking to add it to the whole region, right? Just standardizing that data across 17 states would be challenging.
It'd have to be basic, an estimate of standardized effort, then standardized number of fish collected.
I don't think that's useful.
The vast majority of surveys that you would capture would hopefully have those too.
One thing that I've been asking people, the genetics route is give us some measurement, some metric that can give us a health index of that population. Density, quantitative, so there's so much variability in that, and I just don't think that's useful as far as measuring the resilience or health of the population. So that's what we've asked for the latest stack. Brook Trout genetics workshop was, asking the experts what is a metric out there we can use. We can measure in the field for that population to determine the health of that population. And nobody really knows.
But there's a threshold between 1 and 250 per meter as well.
Right, right.
But at 1,
Correct.
I mean, the basic, it gets down
Thumbs
to,
up.
Mark's old argument for classifying it as, was it trophy to winker scale? I'm sure everybody's heard him say that at least 5 times. So, I don't know. I mean, that's one step, or one option, I guess you could take. But if you wanted something more quantifiable, it gets challenging, and maybe, as Steve said, maybe not